This is the distributive property, lesson 2-4, page 79. Review from last year of the distributive property. It's when we have a distributor being multiplied by the distributed. We used it last year when we were trying to simplify some more difficult multiplication problems. For example, multiplying 13 times 103. Some of you may be able to do that in your head, but it might be a little bit simpler if we take 13 and decide to multiply it by an expression that would equal 103, like 100 plus 3. We take the distributor, which is 13, and multiply it or distribute it through the parentheses. So 13 times 100 would be 1300 plus 13 times 3, which would be 39. So now 1300 plus 39 would simply be 1339. How do you want to break up 21 times 101? We could leave it 21. How can we break up 100? We might say 100 plus 1. Notice, not only in this one, 100 plus 1 is the same as 101, and 100 plus 3 is the same as 103. You need to make sure that what is in parentheses is the same. So now we're going to take 21 times 100 would be 2100 plus 21 times 1 is 21. So we have 2121. You try 24 times 98 on your own. I would set this up as 24 times 100 minus 2. Again, notice that 100 minus 2 is the same as 98. 24 times 100 is 2400 minus 24 times 2 is 48. 2400 minus 48, 48 is close to 50, is 2352. 2352. Hopefully this has given you a chance to review and remember the distributive property. Let's look on page 80 and see how we could use this in real life. Find the cost of 6 pairs of socks that are $2.95 per pair. What might be my distributor? 6. 6 times the distributed is going to be $2.95. What would be a simpler way to write, for multiplication purposes, $2.95? I would choose $3 minus 5 cents. Notice that I didn't put 0.5, I put 0.05, 5/100, meaning 5 cents. When I multiply 6 times $3, I get $18. Minus, when I take 6 times 5 cents, or 6 nickels, I get 30 cents. Therefore, the cost of 6 pairs of socks at $2.95 per pair would be $17.70. That covered example 2 and quick check 2 on page 80. Let's look at the algebraic distribution. Look at example 3. Notice how they simplified the expression 2 times the quantity 5x plus 3. Let's try that same strategy in 2 times the quantity 3 minus 17. I'm going to distribute the 2. The 2 is the distributor. 2 times 3 is 6 minus 2 times 7 is 14t. Can I simplify that anymore? 6 minus 14t. No, I do not know what t is, so I have to leave it 6 minus 14t. And that is an okay answer. Let's try the next one. 3 times the quantity 4/10 plus 1 1/10 c. 3 times 4/10 is 3 times 4 is 12, 1 decimal place, plus 3 times 1 1/10 would be 3 3/10 c. Again, can I simplify that anymore? No. We're going to learn later and review about like terms. These are not like terms, so I must leave it 1 2/10 plus 3 3/10 c. Moving on to example 4. The multiplication property of -1, or the opposite of 1. Let's use some deductive reasoning for a minute. I think I'm going to have potbellies for supper. What if x equals 7? Then the opposite of x is going to equal the opposite of 7. There is not a coefficient here in front of the x. What number could I put? That is correct. I could put a 1. So it is like I'm multiplying everything by -1. So when I get to this example, it's the opposite of the quantity 2x plus 1, or I could rewrite it and say -1 times the quantity 2x plus 1. What happens when I multiply -1 times 2x? I get -2x plus, now I'm going to multiply -1 times 1, which is -1. -2x plus -1. Is there another way that I could write that? Correct. -2x minus 1. Either of those answers would be considered correct. You try this quick check example. -1 times the quantity 3 minus 8a. Hopefully, you were able to come up with the fact that you would take -1 times 3, which is -3, minus -1 times 8, which would be -8a. We can leave it -3 minus -8a, or we could change it to -3 plus 8a. Either of these two expressions would be considered correct. Moving on to page 81, we're going to be talking about like terms. Remember last year when we talked about like terms, we talked about the fact that in order for them to be considered like terms, they must have the same variable part. Whether they have a variable or not, it needs to be the same. So if we look at our first example, negative 3x plus 9x, we have to decide, are these like terms? Well, ask yourself, what is the variable part? And the variable part is x. Are they both x? Yes. So negative 3x and 9x would be like terms. How about 8h and 4j? I have h as a variable and I have j as a variable. Are they like terms? No, because they do not have the same variable part. So they are unlike terms. How about 4 and 15? No variable part for 4. No variable part for 15. They would be considered like terms because their variable part is the same in the fact that they both don't have one. What is another term that can be used when we have 4 and 15? 4 and 15 are considered constants. Those are constants are terms that have no variable. So if you have two constants, they are considered like terms. So let's look at combining like terms. Quick check number 5. 7y plus 6y. Is my variable part the same? If it is, then all I need to do is look at, here's another vocabulary word, the coefficients. One coefficient is 7, the other coefficient is 6. I'm adding them together. 7 plus 6 is 13, and I keep my variable part the same. So 7y plus 6y is 13y. What about 3t minus 1? How would I combine those? You're right, I can't combine them because they are unlike terms. It is already simplified as 3t minus 1. How about 8d plus d? Do they have the same variable part? I have a d and I have a d. So they do. They are like terms. One coefficient is 8. The other d does not have a coefficient. Is it 0 because there isn't anything there? But I have a d. So that means I have 1. 8 plus 1 is 9d. Make sure you've filled in all of your notes, and we will give you your assignment, which you will have the rest of the time to work on.